Now you have 16 minus x squared from 0 to 4. I'm going to draw a little picture of what we're going to do here. 16 minus x squared. Well, if I think of that as minus x squared plus 16, that's a parabola with our vertex here at 0, 16, opening down. And we're wanting to find this area from 0 to, and of course at 4, we have the point 4, 0. So we're finding this area in quadrant 1. And we wouldn't be able to use triangles here. So you don't have to worry about breaking that New Year's resolution. So the distance between 0 and 4, right? This distance is 4. You're going to break that up into n little rectangles. Eventually, we're going to do an infinite amount of them. So first of all, our change of x is 4 over n. So we're going to go through this notation again. And in seeing it again, hopefully some of the things that were really confusing in the first one move to just mostly confusing after the second. How's that sound? Good. Okay. So we've got a bunch of little changes of x's all the way through, starting at 0 and going to 4. This time we are doing lower sums. Does it make sense that our lower sums, since we're decreasing, will always be the right-hand side? It's kind of nice. It's like, well, what do we do with things that move up and down? Oh, more confusion, more pain. But we're doing simple ones right now. Simple. With quotation marks around it, right? So we've got our change of x. We know that's 4 over n. Then your CI is always going to be the right-hand side. So our CI is always going to be equal to our XI, because it'll always be the right-hand side. So it will never be x0. The first one will be x1. The second one will be x2, because it's always the right-hand side. And if I wanted to find C3, does it make sense that C3 would equal 1, 2, 3 changes of x? Because you've moved 3 changes the x to the right of 0. That shows up when I do CI. It's going to be I changes of x. I don't know if that's helpful to write down, because I find this part. This is I, which is a number, changes of x, or it's I of those. And since these are equal to 4 over n, we get 4i over n. Okay? Notation-wise, if you're just copying this down and you see, oh, that's the first place you go like, what the heck? Where did that come from? Okay, well, it's just I changes of x, and we just are dealing with complicated notation. So then f of CI would be plugging in CI, which is 4i over n, into the formula, and you get 16 minus 4i over n squared. Set up our sigma notation. The sum of all of those rectangles will be all of the changes of x times all of the heights. And now we can substitute in, for the changes of x, we can substitute in 4 over n. For the f of CI, we can substitute in 16 minus 4i squared over n. Our goal in this is to simplify it so that we can get a sum from 1 to n of one of the 3 formulas that we had the other day. That's our goal. Simplifying this. We can pull out the 64 over n out of the first one. We can pull out a 64 over n cubed out of the second one. The first one's just a 1. If you add up the number 1 n times, 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, you see that you would have n of them. So this is a formula. The sum from I to n of 1 is adding up n ones. That's going to be n. And here we have the I squared formula, which I know that you all spent last night memorizing. So this n times n plus 1 times 2n plus 1 divided by 6 was like perfect. Life is good. And now it's just simple algebra, right? Of simplifying. Which actually at this point, you are probably more in line to say yes. That simplifying part is a relief. So I multiplied it out, I distribute, and I get 64 minus 64 over 3 minus 32 over n minus 32 over n squared. And if we take the limit up as n goes to infinity, all those ones with n's on the bottom go away. And we figure out that the area under that parabola from 0 to 4 is 128 over 3. Yes.
I guess the fourth part. Where did the coefficient of n come from?
This
Yeah.
this n here?
Yeah.
Okay, so this part here in the green box is equal to this. If you added up the number 1 2 times, 1 plus 1, you'd get 2. If n was 4, you'd add 1 plus 1 plus 1 plus 1, you would get 4. If n was 6, 1 plus 1 plus 1, I get 6.
So it's just the sum of one metric.
Yes, sum of 1 n times will be n.
Okay. That's not confusing.
When you see it, but if you are just looking at your notes, the notation would be like, what the heck? All right.
Keep that up there. More right.